All right, today we are diving deep into something called context engineering. Now, this is one of the most critical, but honestly, pretty invisible parts of building truly advanced AI. You can think of it as the secret language that lets an AI agent actually think. And frankly, getting this right is becoming the #1 job for anyone trying to build the future of AI. So, let's get into it. So, what is context engineering really? Well, AI pioneer Andrej Karpathy came up with the perfect analogy. Think of a large language model, the LLM, as the brain or the CPU of a computer. If that's the case, then its context window is the RAM. It's the AI's short-term working memory. And context engineering, well, that's the whole art and science of managing what information you're loading into that limited RAM at any given moment. And look, this isn't just some abstract idea. The folks at Cognition AI, the team that built Devin, the AI agent that just blew everyone's minds with its coding skills, they said it flat out. Context engineering is effectively the #1 job they have. So when the people at the absolute bleeding edge tell you this is the most important thing they do, you know it's time to pay attention. To give you a sense of the scale of this problem, check out this number. An engineer shared that a single run of one of their research agents can chew through more than 500,000 tokens. Now, a token is basically a piece of a word. So feeding an AI that much information isn't just expensive. We're talking several dollars for just one run. It's actually kind of dangerous. You risk the AI just getting completely lost in a sea of noise. Okay, so how do you actually deal with this? How do engineers manage to tame this context beast? Well, they've got a toolkit of strategies they use to control what the AI sees and what it remembers. Let's break down the 3 main tools in that kit. It all really boils down to 3 big ideas: compress, persist, and isolate. It's like you're trying to answer 3 questions. First, how do we make sure that AI is only focused on what's valuable right now? That's compress. Second, how do we help it remember important stuff from past conversations? That's persist. And finally, how do we stop it from getting all its different tasks and tools mixed up? That's isolate. Let's start with #1, compression. First step, compression. The goal here is pretty straightforward. You want to shrink the number of tokens you're feeding the model. But, and this is the tricky part, you can't lose the important information. It's kind of like turning a super long, rambling meeting transcript into a tight, one-page summary that has all the key takeaways. And you actually see this happening all over the place. Some products, like Claude Code, have an auto-compact feature that does it for you. Other times, engineers will recursively summarize an agent's entire history to give it the big picture without all the noise. Or they might just zero in on one noisy tool, like a search API, and summarize its output before it ever hits the main context. The Devin team even built a whole separate, fine-tuned AI model whose only job is high-precision summarization. That tells you just how critical this step is. But managing what's happening in the moment is only half the battle. For an agent to actually learn and get better over time, it needs a long-term memory. And that brings us to our second strategy, persistence. This is all about how an agent holds on to key facts from one session to the next so it doesn't have to start from scratch every single time. Now, building this memory involves a few choices. First, where do you even store it? It could be as simple as a text file named claude.md or something as complex as a structured knowledge graph. Then you have to figure out how it saves new information. Some agent frameworks, like Reflection, have the agent literally reflect on its own actions to decide what's worth remembering. Others, like ChatGPT or Cursor, just learn from your interactions. And finally, how does it get those memories back? Do you just dump everything in, or do you get clever and only pull out the memories that are most recent, most important, or most similar to the current task? Okay, so you've compressed your context and you've given the agent a memory. The last big challenge is keeping all of that information neat and tidy. And that's where isolation comes in. The basic idea here is that if you just throw everything, instructions, code, web search results, file contents, into one giant long list of messages, the AI is going to get confused. Isolation is all about creating clean, separate buckets for each type of information. One way to do this is with something called a context schema. Instead of a messy chat history, you give the AI a structured form so it knows exactly where to look for, say the user's instructions versus the files it has open. A more advanced move is to run code in a totally separate sandbox environment. That way, a really complex thing like an image file can just be stored as a simple variable name, which keeps the main context window super clean. But the most powerful and definitely the most controversial way to do this is with a multi-agent system, where you basically create a whole team of sub-agents, each with its own little isolated context window. And yeah, this multi-agent idea is a huge point of debate right now because the trade-offs are pretty massive. On the one hand, for tasks you can easily split up, like doing research. A team of agents can be awesome. Anthropic found they outperform single agents. But on the other hand, if you need a cohesive result, like writing a single report, it can be a disaster. The results get disjointed, and some have found it can burn through 15 times more tokens. So the takeaway here is that it's a really powerful technique, but it is absolutely not a silver bullet. So there's our toolkit. Compress, persist, isolate. It feels like a pretty solid game plan for building smarter AI agents, right? But this is where our story takes a sharp turn. Because there's this powerful, kind of counterintuitive idea from the history of AI that puts a giant question mark over this whole elaborate engineering approach. It's called the bitter lesson, and it comes from AI pioneer Rich Sutton. His argument, after looking back at 70 years of AI research, is basically this. All of our clever, handcrafted, human-designed systems, like the context engineering tricks we just went over, they always get beaten in the long run by general methods that just throw massive amounts of computation at the problem. In the end, scale wins. And you can see this pattern play out over and over again in history. In chess, researchers tried for decades to teach computers elegant human-like strategies. And then Deep Blue came along with its brute force search and just beat the world champion. Same story in Go. AlphaGo's massive scale and learning from scratch completely demolished systems built on human expertise. Speech recognition, computer vision, it's the same lesson every time. The clever human knowledge approach gets a lead, but eventually raw computational scale just blows past it. The pattern is kind of undeniable. So this leaves us with two fundamentally different philosophies for building AI. Path one is the human knowledge approach. We try to build in what we know. It helps, for sure, especially in the short term, but Sutton argues it always hits a ceiling. Path two is the general methods approach. You just leverage computation with things like search and learning. This approach just keeps getting better as computers get faster, and it's where all the big breakthroughs have really come from. So is all this careful context engineering just a temporary hack? And this brings us right to the core tension for anyone building with AI today. How do you square this circle? How do you reconcile the very real, practical needs of right now with this bitter lesson from history? How do you build an agent that actually works today, knowing full well that the very techniques you're using might just be made obsolete by a bigger model tomorrow? So what does this actually mean for a developer trying to build something right now? Do you just throw out the whole context engineering toolkit and wait for the models to get a million times bigger? Of course not. The key is to be pragmatic, to build for today, but with a clear eye on where things are heading tomorrow. And that leads to a super practical set of rules for anyone building agents. First, instrument everything. You have to track your token usage so you can spot problems early. Second, be deliberate about your state. Use a schema, not just a messy list of messages, to control what the agent sees. Third, compress your context at the boundaries, especially with chatty tools. Fourth, start simple with memory. A basic text file is often all you need to get going. And finally, save those complex multi-agent systems for tasks that are actually suited for them, like things that can be done in parallel. This is really the practical roadmap for building right now, which leaves us with one last really fascinating question. In this age of scaling laws, where models are just getting exponentially more powerful, is all this clever context engineering a necessary foundational breakthrough in how we build AI? Or is it just a temporary bandage? A brilliant but ultimately fleeting set of tricks that will be completely washed away by the coming tide of pure, raw computational scale? The answer to that is going to define the next chapter of AI. Thanks for watching.